So here we want to use properties of definite integrals to help us evaluate these problems. So on number 3, I have the integral from 1 to 3 of 3 times f of x minus g of x. So I can break this up to be 3 times the integral from 1 to 3 of f of x dx. Now notice I have a dx on every integral. You must write dx every time, minus the integral from 1 to 3 of g of x dx. So that's going to be 3 multiplied by 2, because that was given to us here, minus the integral from 1 to 3 of g of x, which is negative 1. So 6 plus 1 is 7. So now the integral from 3 to 5 of f of x dx. Okay, I don't have anything to do with that here, but I have the integral from 1 to 3 and the integral from 1 to 5 of f. So how can I apply this here? Well, I look at this as the area under the curve from 3 to 5. If I add that to the area of the curve under the curve from 1 to 3, that should equal the area under the curve from 1 to 5. So this area from 3 to 5 plus the area before it should equal that total area from 1 to 5. So this equals the integral from 1 to 5 of f of x dx minus the integral from 1 to 3 of f of x dx. And that equals from 1 to 5, negative 4, minus from 1 to 3, which is 2, so that is negative 6. So that I connected that to area under the curve to kind of see how I could manipulate that. Last but not least, I have the integral from 5 to 1 of f of x dx, but I only know the integral from 1 to 5. So remember, properties of integrals state that if I put a negative in front, that's going to switch my limits of integration. So negative integral from 1 to 5 is going to be negative 4, which is 4.